Hello everyone. This is my continuation of that TIFR 2020 paper PYQ. I did one video on mathematical physics where I solved TIFR previous year question. So this will be TIFR previous year quantum mechanics, and this is a 2020 question paper. After it we will do 2021, 22, 23, all that. Okay. So 2020. Okay. Let's write the question. First question was the wave function of a particle. The wave function of a particle subjected to a subjected to a three-dimensional three-dimensional spherically symmetric potential VR is is given by given by psi x is equal to x plus y plus 3z x plus y plus 3z f r. Okay, f r. The expectation value the expectation value for the expectation value for the operator the expectation value for the operator L square for the state is. Okay, what are the expectation value for L square? H cut square, option B 2h cut square, option C 5h cut square, and option D 11h cut square. So this is the question. The wave function of a particle subjected to a 3D spherical symmetric potential VR is given by psi x is equal to x plus y plus 3z fr. The expectation value of the operator L square for the state is dash. Okay, try this question. Wave function is given psi. Write it as psi r. Write psi r is equal to x plus 3 y plus 3z f of r. Okay, expectation value for the operator L square. Yeah. So this is a three-dimensionally spherically symmetric potential. Okay. So what will you use in spherical symmetric potential? It's a very important topic. It's called spherical harmonics. Spherical harmonics. It's very important and a bit like you have to practice to kind of get the feel of it. You know? So how do we solve this question? First, let me write the spherical harmonics. So spherical harmonics y, okay, y1 plus or minus 1 0. Okay. So this state will have plus or minus 3 by 4 pi 1 by 2 x plus or minus iy divided by root 2 r. Hmm. Yeah, y10 is what? Y10 3 by 4 pi to the power 1 by 2 z by r. Okay, z by r. Right? Yeah. So here, okay, z by r. Okay. So let me write it in a simple way like this is plus or minus. So I will just write plus and minus. So y1 will be what? Y1 and 1 will be so, okay. This should be minus plus. Okay. When this is plus, this is a be minus. So y11 will be minus of 3 by 8 pi x plus iy r, and y1 minus 1 is 3 by 8 pi, so we have because also half, and x minus iy by r. Okay, so now um, if we add these two, okay, let's add these two. So y11 plus y minus 1 1, so y1 minus 1 will be what? Just add them. So we will get root over of 3 by 8 pi if we take the common, x minus iy by r minus x plus iy by r. Okay, so you see x and x will be cancelled out. So root over of 3 by 8 pi. Okay, minus 2 iy by r. Right. So if you see minus 2 iy by r. Okay. So like minus 2 root over 3 by 8 pi y by r. This is y by r. Okay. From here, if you check, this is we can get a z by r value. Z by r is equal to. You will understand at the end why I am writing all this. 4 pi by 3 to the power 1 by 2 y 0 1. Okay. Now we got a y by r here. Okay. Let's get y by r. Y by r is equal to um, root over of 8 pi by 3 minus 1 by 2. Sorry. Let me write it properly. Minus 1 by 2 root over of 8 pi by 3, yeah, 8 pi by 3 y11, y11 plus y1 minus 1. Okay, in terms of okay, my bad, this is y capital Y. Okay, spherical harmonics, y11 plus y1 minus 1. Okay, so now the thing is, okay, how do we got y by r, we got z by r. Yeah, we can also get x by r, correct? So how will we get if I add them? I got y by r. So if I subtract them, I will get x by r. So y11 minus y1 minus 1 will be what? Minus 3 by 8 pi. What was it? X minus x plus iy by r. Okay, anyway, minus root over of 3 by, let me do it simply instead of complicating things, by r. Okay. So if I take minus root over of 3 by 8 pi common, it will be x plus iy by r plus x minus iy by r. Okay. Now if you see y terms will be cancelled out, so x will be only remaining. So root over 8 3 by 8 pi 2x by r. This is y11 minus y1 minus 1. So I got x by r from here then. So this is again minus 2 is coming, right? Or did I do any mistake? Okay, just a minute. Oh, I left I here. The I is there also. I is there. I. Okay, there won't be any minus my wedding. Another mistake here. You won't get a minus here, okay? It's a mistake. So if I take this 2 inside, okay, I can take this 2 inside. This 2 inside will become 4 and it will be divided. So minus I 2 pi by 3. Again, here also you won't get a minus. I'm doing a mistake somewhere. Okay, just check. Minus won't be there. Y11 plus y1 minus 1. Again, here also there will be no minus. Again, 2 will go inside. So this will become 3 by 2 goes inside becomes 4. So 2 pi x by r. This is y11 minus y1 minus 1. So x by r becomes root over 2 pi by 3 y11 minus y1 minus 1. Okay, wait. So x by r I got. Okay, let me write it y by r. Y by r was 2 pi I 2 pi by 3 y11 plus y minus 1 minus 1. Okay, and z by r was how much was z by r? Root over 4 pi by 3. Yeah, root over 4 pi by 3 y10 root over of 4 pi by 3 y. So these three are the terms that we got. Okay, now what should we do now? In the wave function, we'll just put it because we know the wave function, right? Wave function we know. Psi r is we have psi r. Okay. So if I multiply r on both sides, okay, because r is divided here. Okay, so let me write psi. Psi is equal to x plus y plus 3z f of r. Okay. Okay. F of r. Otherwise, yeah. R. So we put the values of we put the values of this. Um, its value 2 pi by 3 y11 plus minus 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 y1 minus 1 plus root over I 2 pi by 3. Okay, yeah, we can do one thing. These are x by r now, we can do like this. Okay, r z is equal to r. Okay, so r will go out. Okay, and this plus 2 pi by 3 y11 plus y1 minus 1 plus 3 whole into what is z? Z is r. Okay. So I can take the 3 inside 4 pi by 3. Oh no 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 no. I can do it. 3 4 pi by 3 y10. So these are the terms I'm getting. So I have to expand it. We have to expand it. There is no other way. And f of r is also there. So r f of r 2 pi by 3 y11 is I root 2 pi by 3 y11 minus 2 pi by 3 y1 minus 1 plus I 2 pi by 3 y1 minus 1, yeah, plus 12 pi y10 f. Okay, so this is what it is. No, f of r I've already written on. So now, Let's, let's do one thing. Let's take the formulas. R f of r is equal to 1 plus I can write like that. So 2 pi by 3 y11, correct? Minus 2 pi by 3 1 minus I y1 minus 1 plus this is as usual 2 pi y10. So now now I will write these things in terms of YLM, okay, because we know what this can be written as YLM, right? So YLM I can write also like this LM, yeah. So I'm writing that form because we need L square expectation value. If you remember the question, it's a big question. Yet we will solve it for R f of R 1 plus I whatever 2 pi by 3 1 1 plus sorry minus and this there is a bracket here 2 pi by 3 1 minus I this is 1 minus 1 plus root over of 12 by 1 0. Okay, so if you see, okay, the thing is this is the wave function. We don't know whether this wave function is normalized or not. Okay. So I can put a normalization form. This can be written as normalization as n, and we can get a normalization from them. So how will you get it? Just square it, n square 1 plus I square 2 pi by 3 plus n square, take it out, 1 minus I whole square 2 pi by 3 plus 12 pi. Okay, plus 12 pi. Um, okay. Is equal to 1. So n square. This is actually 2. This is actually like this. Okay. So 1 plus I mod is 2. Sorry, root 2 square is 2. So this is 4 pi by 3 plus 4 pi by 3 plus 12 pi is equal to 1. So n square 36 pi. 8 plus 30, 44 pi by 3. That is 1. So n is equal to root over of 3 by 44 pi. Okay. This is the normalization constant. Mm, so let me write it again. This whole thing. Psi becomes root over of 3 by 44 pi. What was it? I 1 plus I 1 plus I root 2 pi by 3 1 1 1. Is it correct? Yeah, it's correct. 1 1 minus 1 minus I root over 2 pi by 3 1 minus 1 and plus root over 12 pi 1 0. So yeah, this is the weight function. So we need the this one L square. So psi L square psi. Okay, 344 pi. Okay, this will be a long question coming around. So uh, anyway, we have to do it 1 1. Okay, only the same kind of these things will interact with themselves. So 1 plus I 2 pi by 3 square 1 1. Okay, plus becomes plus. Wait, no, wait a minute, wait a minute. No, 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 no. No, this is wrong. Because the first one will be the complex conjugate. So 1 plus I into 1 minus I it will be right. So 1 plus I, got it? 1 minus I. Because psi star, psi, this is kind of like this, right? So psi star is a 1 plus 1 minus I. Okay. So this becomes 2 pi by 3 because this is real. 1, 1 minus. Okay, minus minus becomes plus. And again 1 minus I, its complex conjugate is 1 plus I. 2 pi by 3. 1 minus 1, minus 1, sorry, 1 minus 1. Yeah, it's a bit tricky, okay? You have to practice a lot. This is 12 pi, 1 0, 1 0. Yeah. So this becomes 3 by 44 pi. This is 1 minus I square, that is 2. 2 into the 4 pi by 3 plus 4 pi by 3 plus 12 pi. Oh my. Wait. No, 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 no. Again, mistake. We have to write the L square value for it, right? I missed it. Anyway, L square value for 1 1, L square. LM. So L is what? L square is what? L into L plus 1 plus h cut square. So this would be what? Root 2, sorry, 2h cut square into 2h cut square into 2h cut square into 2h cut square. The 2h cut square goes out. So 2h cut square. And this is actually the same thing. So 1. Because we got it in normalization. So answer is 2h cut square is the correct answer. So this question took 25 minutes. But if you practice a bit, you can do it in 15 minutes and it will give you like 5, I think 6, 5 or 6 marks in TIFR. I'm not sure. But 5 marks sure. You will get 5 marks surely here. And you don't have to do a lot in TIFR. You have to do very few questions but correctly. Yeah. So this is one. So to solve this kind of questions, you need to remember what? The spherical harmonics. Now you understand why I did all this. We need to solve spherical harmonics. Otherwise, no chance. Okay. Okay, let me write some spherical harmonics for your reference. You'll find it in Jetli book. Okay. Jetli book chapter is angular momentum, chapter 5. So let me write some spherical harmonics from YLM XYZ. Okay. I'm not writing in terms of theta phi, I'm writing in terms of XYZ. So Y00 XYZ is equal to 1 by root over of 4 pi. Okay. Y10 XYZ is equal to root over of 3 by 4 pi z by r. We did it. So, sorry, root over 3 by 4 pi z by r. Y 1 plus or minus 1 xyz is equal to minus plus. Okay, this was a mistake I did. I first wrote plus minus. No, no, that's wrong. Minus plus. That means if this is plus, this should be minus. That's it. Again, see, this is minus, this is plus. Very careful about it. Be very careful. Y1 will be 1 plus or minus 1 is 1. Next is Y20 XYZ. That will be uh, root over of 5 by 16 pi. You have to remember there is no other way. There is no other trick. Now Y2 plus or minus 1 XYZ will be minus plus root over of 15 by 8 pi x plus or minus iy z by r, j by r square. So this one should be enough. I hope. Otherwise, we may write another value. These are capital wise. Okay, my bad again. These are all capital. Spherical harmonics is written in capital Y, not small y. This is capital Y 2 plus or minus 2 xyz to the power of 15 by 32 pi x square minus y square plus or minus 2y xy divided by r square. So yeah, so these are the spherical harmonics we have to remember. Otherwise, we won't be able to solve these questions. Yeah. Okay. So this was only one question till now. Next question. Question number two. Question number two. A fermion of mass m moving in two dimensions. Moving in two dimensions. Okay. It's strictly confined strictly confined inside a inside a square box. Strictly confined inside a square box of side L. The potential inside is zero. The potential inside is zero. Yeah. A measurement of the energy of the fermion yields means leads to, okay? Yields the result, or you get the result like that. Yields the result. What is the result you get? Energy, what you get? E is equal to 65 pi square h cut square divided by 2 ml. Okay. So the question is the degeneracy of this energy state. This question can also be a statistical mechanic question. So anything you can use. 2 number 4 8 and 16. Okay. Same 2022 TIFR question. Formula mass m moving in two dimensions is strictly confined inside a square box side A. The potential inside is zero. The measurement of the energy of the formula is the result. Try this question first. Formula is strictly confined inside a square box of side A. Okay. Energy of the formula in the system. It's formula moving in two dimensions. Yeah, that's a very important term. Two dimensions. So what is the energy? First of all, in two dimensional potential, what is the energy? E nx ny. Nx square, as it is a square well, we don't need to worry about the length. Pi square h cut square by 2 ml. Correct? Yeah. Now what is asked? Potential inside is zero. Measurement of this statement does not. It's not required. Measurement of energy of the fermion inside. The energy is 65 pi square h cut square by 2 ml. So 65 is the one. If we compare the two equations, 65 is nx square plus ny square. Okay, nx is number of components in the x, and alright. So how can I get it? It's very simple. We just have to get some combinations of nx and ny, which will give me 65. First of all, say if nx is your 8 and this is 1, 64 plus 1 is 64. So 8 1 is, so 180 is also possible. What does it mean? It means 8 components in nx and 1 in y. Okay, like that. And how can we divide this 65 into 2? The addition of two square numbers. 49, 49 and 16. Yeah, 49 and 16. That means 7 square plus 4 square. 7 4 4 7. Okay. So any other combination is there? 36, 29. No. 25, 40. No. 16 we did. 9, 56. No. What is that? 4. 61, 4. 61. No. 164 we did. So four combinations. So yeah. So degeneracy of the state is what? 4. Or what? Degeneracy in the energy state is 4. But thing is these are fermions. Okay. So for fermions, so the degeneracy will be 4 into that is 8. Okay. I will answer. The degeneracy will be 8, not 4. It will be doubled in case of fermions. Got it? Yeah. Question number 3. Question number 3. Particular mass m is confined inside a box, confined inside a box with boundaries, with boundaries x is equal to plus or minus L. Okay. The ground state and the first excited state, ground state and the first excited state of this particle, first excited state of this particle are E1 and E2 respectively. E1 and E2 respectively. Okay. Now a repulsive delta function. Now repulsive delta function. Repulsive delta function potential. Repulsive delta function potential. Lambda delta x, okay, is introduced. Lambda delta x is introduced at the center. Introduced at the center of the box. Center of the box, where where the constant lambda where the constant lambda satisfies constant lambda satisfies 0 less than lambda, very very less than 1 by 32 n h by l whole square. Okay, h by l square. So now if the energies of the new ground state, the energies of the new ground state and the new first excited state be denoted as be denoted as E1 dash and E2 dash respectively. Okay, respectively. It follows that it follows that what should be the condition for it? Follows that E1 is greater than E1 dash is greater than E1, E2 dash is greater than E2. Option B, E1 dash is equal to E1 and E2 dash is equal to E2. Option C, option C, E1 dash is greater than E1, E2 dash is equal to E2. Option D, E1 dash is equal to E1 and E2 dash is greater than E2. Please try this question. It's a very good question. Okay, could you solve it? See, okay, let's see what is the question. Particular mass n is confined inside a box of boundaries x is equal to plus or minus L. The ground state and the first excited state of this particular E1 and E2 respectively. Now repulsive delta potential from function potential lambda delta x is introduced at the center of the box where the constant lambda satisfies. So, let's go now. This is kind of repulsive delta function potential. This is kind of a question from what? From perturbation, right? Perturbation question. Boundary is given. Then a delta function potential lambda delta x is given, which is I think is the perturbed Hamiltonian. This is the perturbation. This is the change that is disturbing the system. That means this is the perturbation. Okay, so I can write the perturbed Hamiltonian the perturbed Hamiltonian, okay, H dash will be what? Lambda delta x, delta function potential lambda delta x. Okay. This is the what kind of potential? Confined in a box with boundaries x is equal to plus or minus L. So only x is given. That means it is a only one dimensional potential, and box one dimensional square potential. Okay. So one dimensional potential we know psi x is equal to what? Root over of 2 by L. Length is plus or minus L. Yeah. So 0 minus L L. So this is called a what? Symmetric potential. Okay. If it was like 0 to 2L, it would have been called a symmetric potential. This is a symmetric potential. Root over of 2 by L. Okay. Sine pi x by. Okay, sorry, my bad. Okay, root over 2 by 2L. No? Because the whole length is minus L to L. That means 2L. Yeah. So root over 2 by 2L sine pi x by 2L. So it kind of becomes 1 by L sine pi x by 2L. If it was minus L by 2 to L by 2, then it would have been the total length L, so 2 by L. Okay. Yeah. So 1 by L sine pi x by 2L. Okay. Pi x by 2L. So this is, if you see, this is what? Okay. Quarter Hamiltonian, and the condition is given as 0 less than lambda, very less than 1 by 32 m h by L whole square. This is the condition given. So correction on the ground state we can easily do. We know correction, how we will calculate correction. H test, right? Expectation value of H test. 1 0 in the ground state, first order correction in the ground state. First order in the ground state. Ground state is 0. First order 1. Okay. No, ground state is no 0, but it's written like that. Okay. So minus psi 1 star H dash psi 1 dx. Okay. And what should be the this limit? Hmm? Limit should be minus L to L. It's not defined anything. So minus L to L. So simply 1 by L sine square pi x by 2L, and the lambda, the delta function potential lambda delta x dx. Okay, so this is minus L to L. Alright, so all let's take all the constants out. So 1 by L into lambda. So minus L to L sine square pi x by 2L. Very easy integration. Whenever delta function comes in, the integration becomes easy, because actually the definition of delta function is what? Fx delta x minus a dx. Suppose this is minus something to something, alpha to alpha. So if a exists, if a lies between alpha minus alpha to alpha, or suppose alpha to beta, if a lies between alpha to beta, then this a will be directly put in fx. So the answer will be fx. The integration, the answer will be, solution will be fx. So here x minus 0 is there. So 0 lies between minus L to L. Yeah, I just so yeah, so yeah. So let's put 0 directly in place of x. So the integration becomes 0. Is it? Or did I do any mistake? Oh, this is ground state. No, I made a mistake. Ground state. This should be cos. Okay. Symmetric potential ground state is cos, and first okay, ground state is cos. So this will be cos square. My bad. Be careful about this things. Okay, this can be a bit confusing. Yeah. So this will be what? 1 lambda by L. Put cos 0 is 1. So this becomes 1. Okay, very simple integration. So this is your first order correction is lambda by L. Okay. Alright. So new ground state energy will be what? If I write new ground state energy, new ground state energy will be E1 is equal to what? E1 the, okay, let me write it like E1 1, something like that. E1, the original one, plus the perturb, there is a change in energy. So E1 was what exactly? E1 was suppose E1. They're not giving any specifics. So u1 plus u1, and this one will be lambda by n. Okay, this one will be lambda by n. So if lambda is a positive constant, okay, because we have written here 0 lambda, sorry, oh sorry, 1 by 32m h by L whole square. So m is positive, this thing is positive, so lambda is positive. So this thing is positive. That means the new ground state energy is what? Greater than E1. Got it? Because I'm adding a positive constant to E1. That means the new ground state energy will be greater than E1. Got it? Yeah. Okay. So is it there in any options? We can just finalize it. This option is correct. Okay, there is another option here also. Yeah, so we have to check the other one. Otherwise, we could have just simply gone, finished it. Anyway, okay. The first excited state. Okay, this is the one. First excited state. That means psi 2. So psi 2x should be what? 1 by L. Here it is sine. Okay, sin x by 2L. Okay, this is it. So yeah, the integration of it we got 0 in the previous case, so we can just directly 0. So energy E to 1 or whatever, we can write E to original plus this is 0. So E2 dash is E2. Okay, got it. So otherwise, if you are confused, how see this is a symmetric potential. Okay, and this is an odd function, so it will be 0 only. Okay. Um, which one then? E2, yeah, this one. This is that. Option C is correct. Option C will be the correct answer. Yeah, that's correct. Yeah, got it. Alright. Right, one more question. Yeah, question number 3 now. Question number 4. Partic- a particle of mass m, particle of mass m is placed in one dimensional one dimensional harmonic oscillator, placed in one dimensional harmonic oscillator. Okay, harmonic oscillator potential, harmonic oscillator potential. What is it? Vx is equal to half m omega square x square. Okay, so at t is equal to 0, t is equal to 0 is wave function is psi. Wave function is psi x. Sorry. So wave function is psi x. So t is equal to at t is equal to 2 pi by omega. Okay, its wave function will be its wave function will be okay. The options are psi x, option B minus psi x, option C minus pi psi x, option D 2 pi by omega psi x. This is the question. Particular mass m is placed in one-dimensional harmonic oscillator potential Bx is equal to half m omega square x square. At t is equal to 0, its wave function is psi x. At t is equal to 2 pi by omega, its wave function will be right. Nice question. Okay, let me do this one. Uh, See, particle like at t 0 is psi x, right? But at time t it changes. I think changes xt. How we write it? Psi 0 x e to the power. And it's very easy question. E n- I e naught t by h cut, right? So psi naught x. Okay, what is e naught? What is the e naught? E naught is E n is what for harmonic potential? N by half h cut omega, right? So what is it? Half h cut omega. Okay, e to the minus I h cut omega by 2 t by h cut omega h cut. Okay, sorry. So I psi naught x e to the power minus I omega t by 2. Okay, I omega t by 2. And time is given also. Time is given 2 pi by omega. So let's put in place of time 2 pi by omega. So psi naught x e to the power minus I omega by 2 into 2 pi by omega. 2 to 1, omega omega gone, so e to the minus I. Sin naught x e to the power minus I pi. Okay, we know. Okay, what is e to the minus I pi? E to the power I theta is what? Cos theta plus I sin theta. So e to the minus I pi will be cos minus pi, that is cos pi, and sin minus pi is 0. So minus 1. Okay, so this is your psi xt is equal to minus of the original one. Got it? Yeah. The answer will be. I hope you got it. Yeah. All right. Right. Okay. Write a homework. This one you will try also. Same here question. Question number 5. Three non-interact three non-interacting three non-interacting particles whose masses whose masses are in the ratio are in the ratio 1 is to 4 is to 16 are placed together are placed together in the same in the same harmonic harmonic oscillator potential, Vx. Okay. The degeneracies of the three energy first three energy eigenstates ordered by increasing energy will be dash. The options are 1 1 1, option B 1 1 2, option 3 1 2 1, and option D 1 2 2. That's it. Okay. So yeah, let's try this. Question, this is the homework, and we'll be solving more questions in the next sessions. Okay. Yeah, that'll be it. Thank you very much.